Alright, welcome to yet another video on our Formatables Refactor. We seem to have a few problems with the camera lagging a bit. I've tried to resolve that, but I don't think it's fixed completely, so you'd have to bear with us. So let's try to remember where we were. But this is the time we spent trying to resolve the camera issues. Let's make sure we have a fairly up-to-date code generator, and let's make sure as well that code generating results in no differences other than our backlog. So first let's try to get back to where we were. I think there's a few things that were done that were not recorded. So we managed to get the C# locator moved over to the new transforms. So that was good news. That's all working fine and dandy. So as you can see here, the C# model now does not have a locator. Getting closer to the end of our refactor here. On C++ though, the battle still rages on, and the problem is, of course, C++ is much more complicated. The problem is inclusion expansion is tricky in C++. So where we were then is we must have been trying to understand how the inclusion processing was working. This is the bit where we need to reload the state from some time ago. Let's try to understand what we're doing. Yeah, so we were creating the inclusion directives, which basically meant that the artifacts themselves contain some properties related to the inclusion directive, which is nice. And the problem was, so in the old world, we had a repository that contained all of the directives, and this was organized by logical ID and then by physical ID, which meant that by the time it came to populate the inclusion dependencies, we could rely on this repository. The builder would do a lookup on the repository to find the appropriate includes, and then would add that to well, that would be the inclusion expansion, I believe. And those guys would then go into here, the inclusion dependencies. And then all we need to do is to format those guys correctly, and away we go. And everything will be very easy. We now need to do is we now need to somehow simulate that ability to access things by logical ID and by string, because at the moment the physical model doesn't have that ability. So we have artifacts. They live in regions, and these regions are very how should I put this, they're not very easy to query, because the region is not designed for querying really. It's just a region of a logical physical space. So we have two options here. We can create a construct inside of a transform that contains the dependencies, and in effect something like this. And then just basically do a loop through the model and populate these guys here, which is probably the easiest thing to do. But also, let's just have a bit of a moment to think about what the end result is going to be. So this is kind of like the intermediate world, but the final world, if we have a think, in the final world we have relationships, right? And these relationships, well, we have meta relationships, which are the relationships between artifacts, archetypes, sorry. And these relationships then are sort of the template for the relationships, and they get instantiated with logical elements. And once these relationships get instantiated, we can then populate. This is quite tricky. We just have to keep in mind where we were. So we get relationships, and the relationships instantiate, so the meta relationships instantiate with relationships, and then these guys here are then equivalent to the inclusion dependencies. So presumably there is going to be a need for a lookup based on but in the new world this is a two-step process, yes. So we encode the relation, basically stating that an archetype. So the idea is that an artifact has a relationship against other artifacts, and that then means that I don't necessarily need the directives anymore. It's not very obvious actually how this is going to work. Perhaps, and this is one of the problems of working with metadata really, it's just that everything is so metadata, sometimes it's very hard to understand where you are in terms of the sort of abstraction layers. So what we're going to do instead is we're going to forget a little bit about the end use case, because I think that's quite hard to picture in your head. We will skip that for now and just focus on solving the current problem at hand, because I think that's going to help us visualize the end result a little bit. And I think the easiest solution for the current problem is to just have a container just like this guy here that gets generated, and now we'd have a good name for this map, well, this key here you see in this map, and that is actually a logical metaphysical ID. So what we can do is we can create this logical metaphysical ID, these entries, and then actually I also believe that a region should have a logical metaphysical ID. Now I think it doesn't. Instead it has a provenance, and the provenance contains the logical provenance. So I think really what we should do is we should make sure regions have logical metaphysical IDs. Oh, in fact, the region can't have a logical metaphysical ID, of course, because the region will have multiple physical IDs. But what can have a logical metaphysical ID clearly is the element. So let's have a look at what an element is. An element is nameable, and the nameable is a physical name. Now the physical name is only focused on the physical aspect of the logical physical space. So we really need some kind of way. Of course, then you will say, oh yes, but it's got a provenance as well, and that contains a logical provenance. Yes, that's all fine and dandy, but really what I want is, if you're an element in the physical space, you should really have a point. There should be some kind of way of knowing what is your point, and then in the logical physical space, and then with that point then it'll be very easy for us to then say put that in a container and have a container with all logical physical points and their inclusion directives, and that's exactly what we're going to do. So let's just start with that then. First we're going to need a good name for this concept, which is not a very easy thing to name. E3B. Let's think. So the object template will be something like, well, let's think about the property first. We know its type. No, actually not that. The type is going to be a logical metaphysical ID. And that's on the identification model. Point in logical physical space represented by this element. And the name of this is going to be, well, I would like to call it ID. We have a name. I mean, ID is really not the best of names, but this is what we're trying to say, that you have an identity in logical physical space. So perhaps it's a logical physical space identity. It's not really obvious how we should name this concept really, this template, but it is something along these lines. What we're trying to say is that you have some kind of identity in logical physical space. Now remember, you're an artifact, which is sort of an element of this space. well, we will just leave it at that for now. It's not the best of names, but it's good enough to get us going. And that's important, because otherwise we will sometimes we have to just do the first draft of something, and then that allows us to think more about the subject, and then we get to slightly better naming. Make sure this is correct. Right, so now then, we have the notion of an identity in logical physical space. Of course, that's not the right logical name for this chap. And I think we need to move this guy here a little bit. So then, perhaps we could bring a bit out of space, really. The walls of having a graphical representation. Continue. So there you are. So we create this notion of a logical physical space identity. The identity is really made up by the logical bits of the logical provenance and bits of the name. Bit of duplication here, but there you are. It seems to me that we should really do that. Of course, we could just create the identity on the fly, but it seems to me that it's a fundamental property of an element in logical physical space. We do have properties like provenance, which is really it is a property, and we have obviously some kind of identification, but I think this is a separate property of an artifact, a point in logical physical space. So that being the case, then we should just go away and generate this chap. Make sure we save it. Let's see what happens if we try to generate this. And I think we probably will need the usual conversion and indentation. It's will be nice when you move away from JSON, because at the moment it's just costing us for no advantage. But to be fair, as I probably mentioned in videos before, it was useful in the beginning because it enabled us to see. We would have hard-coded a lot of things were it not for having JSON and other models. So this is going to take a little while to do this compilation. So if we, when we started, we tried from the beginning to have more than one of things. So for example, in the codec world, as you can see here, let's remove our rulers. In the codec world, we have a codec model, which is sort of a general non-codec specific model that has this very simple model, and then we have the specializations such as dia and JSON, and like this guy here. And you may have thought, oh well, I mean, we only use dia really. JSON was kind of like some idea that never really took off. And it's true that really dia is the main model, but what would have happened is we would have hard-coded everything to work with dia without noticing we were doing that. And so the good thing about having two codecs was, during this development phase, was that it made us think about what belongs in the dia codec and what belongs in the general processing pipeline. And what that will allow us to do now is, once we finish with the refactoring here, there's still one bit that we need to do. We need to move this graphing over to this guy here. But once we do that, when we add the final codec, the codec that's actually going to be the one we're interested in, which is org, we can then deprecate both the dia and the JSON codecs. I mean, they can stay there, but we just remove all the tests and all the stuff we got around it, or maybe just remove the code as well. And that would then allow us to move to the final destination in terms of codecs. And with that, in the future, if we do really have proper use cases for codecs other than org, we are hopefully, we don't really expect to do huge amounts of work in codecs because we now understand the pipeline and the architecture quite well. So hopefully this means that all the really difficult decisions have been made already. Okay then, so here we are. We have a very simple thing that code generated for us. You can see here we have this new property. We'll just commit that. Physical add IDs to artifact. There we are. So this is really simple. All we've done is we added this ID to the artifact. And now what we'll do is we populate them. So we must have a projector somewhere, a logical to physical projector. This guys here will be generating things like the provenance. Here we are. And the name will be around here somewhere as well. Processed IDs. So we're about to create a region. The region has a provenance. At some point here we'll create an artifact. And there we are. The artifact has an ID, a provenance, and here, right, what we're going to do is we're going to change things slightly because we already used the name ID. That will probably be a bit confusing, so let's just not use the name ID just yet. And let's make the logical physical ID. So it's going to be something like identification entities. It's slow LSP today. And we want the whatever that was. Logical metaphysical ID. It would be nice to have a much briefer name. So the logical metaphysical ID, very long name. Everything's slowing down at the moment. The logical metaphysical ID will have a logical ID, which is going to be, actually to be honest, I will keep the ID as we had it before. Just call it something else, logical ID. Probably do the same for the physical ID. Right, there we go. So create the factory. So first we remember these guys here. Then we create a factory. Factory is used to generate these chaps. Here I'll say your logical ID is this. And well, actually, to be absolutely honest, I wonder if we should. Oh no, this is fine. And then the physical ID. Physical. Okay, so we just have to be careful. This is not a physical ID. This is a physical meta ID. Physical meta ID. Okay. And then finally, a not ID is this thing here. I mean, we could of course say, I wonder if this code would not look cleaner if we just do something like a.id dot. And I don't really like, I normally like just setting things once and rather than start interfering with the properties at the low level, but sometimes what's really important is the clearness of the code, and that seems to be pretty clear. If I look at this, then we could say here, set up identification properties for the artifact. So at least we have a group of related properties in here. Now let's think about the comment as we had before. So populate the provenance properties for the logical and physical dimensions of the artifact. To be fair, I think that is really what we're doing. Name, identity. Can spell today. We are in Portuguese. Interestingly enough, it seems to be in Portuguese. There we go. So some words are Portuguese. I think we have multiple multiple dictionaries, so that's fine. Right, there we are. So I think this should give us what we want. Shouldn't really make any difference to anything, so clear test is just going to pass, unless we broke the world. And let's see how we're doing for time. So we're going to try to keep this to about an hour and a bit. So we've got another hour to go. Okay, that looks good. And as usual, we'll just give it a quick spin, make sure the generator still generates. And here we can say populate the LPS identity properties for artifact. Very simple, and clearly our generation did not cause any problems, so we're good. Right, now then, now we have those properties populated, we should be able to go to our transform and create some kind of clever method that has the job to create one of these guys here. So we really want it to be, now I think we added directives or some kind of concept of directives, if I'm right here. Yeah. So we need an unordered map. Let's think, stood unordered map. Not exactly that guy. And it's going to have one of these guys, and it's going to have, do we have a map already? No. Right, so it's going to have one of these guys. It's going to have a logical, metaphysical ID. And that's inside of identification, entities, and it's going to have, we're in physical, so we just need entities here, right? So something like this, and we could call these make global inclusion directives. Right, and there our job will be to loop through the model, as you can imagine. And you probably need to make this static, because everything is static. Right, so the job of this guy is finds all inclusion directives in the model and indexes them to logical physical points. So that should be very, very simple. I probably like the word create better than make. And global, well, you know, remember this is just temporary code, so it doesn't have to be perfect. And this will be just next to process artifacts. But one wonders if, oops, I think this is a category of its own, because this is going to be related to new set of functionality in this transform. Which is becoming quite big, really. Okay, there we are. So, too big. Okie doke. So now then, process artifacts is which is really not a very good name, because we need a different name for this method. It's doing computations of the path and so on. So in a second we will rename that guy. I mean, like I say, this is all temporary code, so it doesn't really have to be absolutely perfect, but just needs to be good enough that we can live with it for however long it still exists. Right, so this guy here will do something like we probably have regions, I guess. and these regions will exist in the model. So it's going to be a region pair, and if I just do a const auto region pair dot second, and then if I just do a for const auto by ref, I don't know what this is going to be, but region archetypes, artifacts by archetype, so clearly we don't need more than one pair, so let's call this the region pair, and this is going to be the artifact pair. Now then, we are getting to the artifact, and in here what we really want is the artifact itself. By convention we call it A. Now this is probably a pointer, so we can just dereference it. And now that we have the artifact, we can finally do something like the pair that we want to insert. That's going to be a student make pair. And that's going to be basically something like the ID of the artifacts, comma, the artifact dot. Now we just need a bit of help from the UI. Path properties inclusion directory. So right, let's be big. So let's just grab them here. Let's call these the actives. And there we are. And then if we could then say and we can just do something as simple as insert the pair, and we expect this to work. Let's just throw something. So if you're not inserted, we want something like duplicate point in LPS. One thing we don't have at the moment is a good way of outputting LPSs, so let's just use this string stream and output our LPS as follows. A.id, logical ID, perhaps a dash, I guess, and then physical meta ID. And while we're here, of course, since we're doing that, might as well say that the duplicate LPS is also part of the stream. That could be part of the message as well, and then that would do the trick. And then const auto MSG os.str, and just dump the message to the stream. And hopefully that will take us there. I mean, we don't really, of course, expect any duplicates. Sometimes I guess we end up in doing a bit of defensive coding. I mean, but then again, it is possible that there are duplicates. We must bear that in mind. Remember that the regions are not organized, so we are assuming there are no duplicates. So I think that whenever you have an assumption, you should probably make it explicit. Mainly because we refactor a lot. So something like pointing physical already exists. Okay, so we don't really expect duplicates, but because we don't really expect duplicates, we should really make that expectation obvious, because, oh sorry, we need to do a value of the IDs, because these are primitives. Right, so we have a message here. Right, cool. So this thing here then is inserting our points into this guy, creating a container very similar to the previous container. So you could quite easily come here, and so this is kind of like a two-step transform really. This guy here is processing and in fact this makes me wonder whether we should really put all of this stuff in the same transform. Let's have a look. I think we created a separate, oh yeah, so we did create a separate transform for this. This is the problem of doing things occasionally. Right, okay. Oh, okay. Worse than that, we've actually started doing this work before. See, this is a classic case. What I was trying to say before of when you, because of the nature of the work, and you spend so much time away from the code, that you forget what you've done already, and then it takes a while to load up state, and then you end up duplicating work just because you didn't check properly. Okay, I think that's sensible. And let's have a look at these two guys. Okay, so what we did before, so in a way there's a win here, because before we thought, okay, let's just do this locally and create the logical physical ID locally, which to be fair is one possible approach. However, today we decided to make that part of the model. Now I prefer the second approach actually, of making it part of the model, because I think it is part of the model. I think it's a fundamental property of the model. And I think I like the new implementation a little bit better. Except I don't mind duplicate ID. That's fine. So this is a classic example. I mean, one of the things we try to do in these videos, a bit like the chap that does the Serenity OS videos, where he says that one of his objectives is to make sure that it gives people a realistic view of what development is like. We try to do that here too, and you can see here what just happened here is exactly what happens all the time when you've got an open source project that you work on when you've got some time. You forget what you're doing. You completely forget what you're doing, and then it takes you a while to load up state, and then when you load up state you then miss bits, and then it's just very haphazard. It's very different from when you're working on something every day for 5 days in a row. It's difficult. Now then, so we've already got the inclusion directives. They already are being populated. We made this slight improvement here of using the ID, which is, so it's not a complete waste of time. This time we spent, and hopefully, how are we doing for time? We are 30 minutes into it, and let's have a quick look. Family stuff getting in the way as usual. Right, cool, that's good. So now let's just see what that then does. Probably don't need any of these. We do need these. So physical, minor. So use artifact ID when building inclusion dependencies. Okay, so now we just use the artifact ID instead of creating our own, so that's good. Okay, so now we are where we were last time, and what that means is we now need the second part of this work, which is, so we got the inclusion directives in the right shape, but the second part of this work is the tricky part, because now we can't just simply say, oh, please give me inclusion directives. What we need to do instead is we need to identify the artifact, identify the population function for that artifact, and then obtain the dependencies. And what I mean by that is, oh, and in addition to that, we can't even do this. No, that we've made a very big we made a very big error in modeling. We're in a physical model at the moment, so we got no view at all of the logical model. And because remember, this is a transitory between the old world and the new world. This is a sort of an in-between step. In the new world, we have propagated the relationships over to the physical model via this fairly complicated contraption we got here. It still needs some tidying up. So in this world, we do remember the relationships between logical elements at the physical level, because they are either encoded directly on the properties of the meta types or on the types themselves. However, in this in-between world, there is no way to know what the relations are, and there is no way we can use these relations, because that was the whole point. We were finding this very difficult to do. So we tried to create this in-between step. So we need access to the logical model in order to populate the physical model. Now, that means that this theory of ours of doing this transform in the logical model is a bit flawed. Because, so let's just make this a bit more concrete, because you're probably wondering what I'm talking about. So if I take a template, you see here, this is the inclusion dependencies population function. And each of these is associated with an archetype, such as this guy here. Now, in this particular case, there is no need for the logical model, because of course it doesn't refer to a logical model. But if we take a more typical case, of which there are plenty, such as say a class implementation, and we take that template, what you'll see here is you'll see that we spend a lot of our time going through the physical model, the logical model, reading bits of properties, and then using those bits of properties to determine what the inclusions are. Therefore, this cannot be done directly at the physical layer, because we need to be able to do this. We need to be able to obtain the logical model element, we need to know its relationships, and that's only available in the logical model. Now, this is a bit of a problem. This means that this transform can't live where we thought it was going to live. And we have a bit of a weird dependency now, because in one way we need to compute things such as paths in order to be able to compute the dependencies, because of course the paths will give us a relative path and we need to compute the dependency. However, that's only done in the model population chain, which, if you remember, let's close a few of these guys here. If you go back to the orchestration model, if I could click correctly, there are some of the weird diabugs. So, what are we showing here that we shouldn't be showing? I don't know why we have these X's in the objects. Well, there we are. Seems to have sorted itself out. So, what are we saying then? We are saying that we have a problem because when we enter the logical model to text model chain, we do a projection from the logical space to the physical space, which is fine, but this is really the last point at which the logical model and the physical model are connected. Well, that's not strictly true, of course, because the text model contains both. But we were hoping not to put too many transforms in this space. We were hoping that the only transforms you'd see in the logical physical space would be the text generation. Now we're saying there's a second requirement, which is we need to compute the dependencies, just for now. How do we resolve this problem then? Well, one thing we can do, so perhaps what we need to do is we need to go somewhere halfway there. I mean, ideally what we really wanted is to get rid of these functions in here. We really don't like them here. They're just not ideal, because this is not the final interface of the text transform, and we want to get to the final interface as much as possible. So that would be the ideal thing. Okay. Okay, so the ideal thing would be if we could get rid of the inclusion. In fact, to be honest, that's the target here. Really, we want to get the templates as close as possible to their final shape, even if that requires a bit of hackery. So that's the first requirement. The second requirement then is we need some kind of way of doing this in a logical physical space. And at the moment, the only guy that's got visibility of that is the text model. So, in fact, I wonder even if this guy shouldn't really be called logical physical. Because if we did that, then all of this would then make more sense, I think. The text model is... No, not the text model, but in fact, let's just say that... sorry, this is another thing that happens to us all the time. We start doing something and think about something else. Let's put a note here just saying, consider renaming text to logical physical. This is really the right name for the model. I do not like this autocomplete, so I'm just going to disable company mode. This is really the right name for the model. The text processing part are the transforms that are done on the model. So this is enough for us to go back to this when we have time. So okay, so here what we're calling text, the logical physical model, and then actually, sorry, let's add another note here. So if we do rename the model, then we can just say to just read you. Right. So at that point, so then what we're saying then is, how can we add a transform here? And that could somehow do the job. Now remember that these transforms are executing in the context of producing a logical model to text model chain. So they're going to execute... Yes, we need to understand when the order of execution here. Let's have a look at that chain. Let's call the logical to text. Logical model text model chain. So in each of these guys here, so we start off by creating, well, we're just copying across the logical model. Then we must generate the physical model somehow. Yeah, this is the projector, and then we create a physical model, and then as you can see here, after creating the physical model, we then work on the population chain, which is the set of transforms that we were talking about a second ago. So somehow after we generated the physical model, what is not very clear here is where do we run the text transforms? I think we're generating the text model, and then after generating the text model, this is a bit weird. So we generate the text model. As you see here, we have a text model to physical model transform. I mean, this transform should be absolutely trivial now, but I think there is some kind of hackery going on here. I think the text model to physical model is actually running the text model transforms. No, actually it's just basically obtaining the physical model sets. So this is actually an absolutely trivial transform. We probably don't really need this guy here anymore. But what we do need to understand is how did the text model area. So there's a text model production chain, which runs the text transforms. Okay, here we are. So I wonder if what makes more sense then is to go to the text model itself in the model generation chain and generate another chain here. And we just have to remember how the order of execution here is very, very crucial. So if I just put the logical model, text model side by side with this guy here. So this guy here is running a whole load of transforms to convert the logical model to a text model, including the model population chain. Nothing would stop us from having a transform in this chain that updates the dependencies. And then by the time the key thing though, the most important thing of course in all of this is that we must get to the model generation chain with the dependencies populated, otherwise of course it's not going to work. So somewhere before that we have to populate it. Now there is the text model production chain, which at the moment has got these two steps in it. There is the model population chain, it would make sense to populate, since we are making changes to the physical model, it makes sense to populate that before we enter the model generation chain, of course. So it has to be here somewhere. So we need to create a transform. What is annoying about this is that we don't really want to add too many transforms at the orchestration level. These are very high level transforms. We could add a step to the logical model to text model chain. Would be a bit dodgy really, but we like these things to be real transforms, so either chains or transforms. Chains should really call transforms, and transforms should just do one thing, because then it makes it really easy to observe the inputs, observe the outputs, and see if the transform is doing what it should do. In few cases we have things like the projector where really this should probably be a transform that calls the projector, but there we are. So then not easy to decide here. Where should we put this little transform? Well, what we know for sure, absolutely certain, is that it cannot live in the physical layer, because that just does not work. So whatever happens, we need to copy this guy here somewhere else. And we also know for sure, well, I wouldn't say for sure, but it doesn't make a lot of sense to put it here, because it's going to be disconnected from the model generation chain. This is only a legacy transform, and we only need it for a short-ish period of time. So I'm going to go and add it here. Again, if you remember, there's a bug in Dia that makes copying and pasting a pain in the backside, so we will just copy things manually. So we'll just add the transform here. And E5E is its color. It's sad that we lost the ability to run Python inside of Dia, because that used to make our life easier. But it's one more reason why we really need to move away from Dia. Right, so then we need a context. And we need a model. Now then, so I think we probably should take the context from the text transforms. We don't really need a global context. That would do. So what are we trying to say then? We're trying to say that in order to do this, we need to see both the physical and the logical model. So the text model is a logical physical model, so it's the right place to do this in. We will call the projector there. Call this guy from here. And hopefully this will make some sense. So the legacy dependencies transform will now be called from the logical model text model chain. It will be called just around here somewhere. Clearly after we've generated the physical model. Just here. We will populate all the dependencies, and then that will then result in updating the inclusion directives, the inclusion dependencies. It will contain a whole lot of functions which we're going to remove. We're going to copy from each artifact. It will be very dodgy, very hacky transform, because what we'll do is we will loop for every in fact, one thing we need, which I don't think the logical physical model gives us in a nice way, we need really yes, brilliant. So the logical element is part of the logical physical region. This is great. So that basically means we will loop through the logical physical regions, and in each logical physical region we'll obtain the element, then we will cast the element to the right shape, we will resolve the element to the right derived type, and then once we got the right element, we will then say for each artifact and that exists in the region, and then for each artifact we will locate the right function of that artifact. Let's have a look at how the function looks. And in each function we will just obtain the dependencies with this builder, which can be a very simple thing now, and the builder is just doing a lookup and adding things together. And then once that's done, then we can slot in the result of the builder back into the physical layer, into here, inclusion the dependencies. And then we just have to comment out the old world, the new world, and away we go. Okay, so this looks foolproof. So let's just do that then. While we're there, since we're doing some generation, let's think about how this builder is going to work. The builder will need to have notions of the logical model. So I suspect it has to live in the text model. I should think. Let's think about this for a second. The builder will be and the interesting thing, of course, is that the builder probably needs access to that container, because otherwise it would make a lot of sense. Let's just see, do we really need a builder? I mean, I think the builder could just be copied directly to yes, I think the builder could be copied directly, because if you look at these methods, they are really trivial. So we're not going to bother with the builder. We will just add this directly to the transform. This is going to be one gigantic transform, I'm afraid, but there is no other way. Okay, cool. Good. Orchestration, new transform. Right. So the first thing we're going to do then is going to just try to move across this transform. This should be easy enough. So we need to generate this model. We will need to convert the orchestration and right, so these two guys here are the ones I'm really interested in. So legacy dependencies transform. We should probably, of course, run the test, make sure that we didn't break the world. Very likely we did. And then what we'll do is probably just checking these cosmetics that we've done to these models. Okay, we've done a few changes here. I don't particularly care when these things change. Just don't want this to be my diffs. So physical and text.cpp models. It will be nice when we move away from dia to not have these previous diffs, because in the text model anything that changed will actually be important. Now then, so what we'll do is we'll just do something very simple, which is to say, let's take the legacy dependencies transform, and as you can see, we can see both of them here. We'll start off by taking one of these, in fact even the logical model text model chain, because these are working at the right model level. You can see here the helper is trying to give us the includes. Education should probably go first. So what do we need? Yes, the problem is we probably need a text. Well, I suspect we need to operate at a text model set, really. We probably don't need a... do we need a complete context? We probably don't need a complete context, so we probably, if we just work at the model set, I should think. And then if we take the context from text as well, with a bit of luck, this would give us what we need. So this guy will say, well, it will give us an up-to-date model set, and it will use the text entity, no transforms even, context, and will output, funny enough, well, to be honest, this is just an update in place, really, and it's no longer constant. Okay, so we will take a text model set, which is a model set, and then, of course, what we'll do is clearly we're going to need something that will do the exact same thing but on a model basis. And there you are. So this will be what this transform is going to do. We will just go to the CPP. Should have probably copied across these two methods. Right, so what we'll do here in the CPP, we need to copy across these guys here, right? So let's say we take these guys and we will need something like this as well. Right, so then we will need perhaps some metaphysical IDs, some maps, perhaps even a physical model, I suspect. Something like this. So that guy then will then do the computation of the inclusion directives, and we can literally copy that across from here. Not from there. From here. And I guess at this time it's probably a good opportunity to get a lot of this stuff. I assume we will need some transform exception from orchestration. Not sure if that exists. It does. And then we need to set up the log. Be nice to have all of this already in the template. There's so much potential for automation. It's a shame we don't have the time. Because we could literally make development so much faster. It's the paradox of Dogen that in order to make Dogen faster, we need to develop Dogen. It's not liking something. Oh, inclusion directive somehow. Oh, right, so we need to say this is a physical thing. And clearly we are talking about physical model here. So hopefully that will make it a little bit happier. And then using physical and physical. There you are. So now then, we are computing the inclusion directives as we were before. We could do with a bit of tracing. We will need some kind of model I/O. This particular case is going to be not the text model, but not the physical model, but the text model. And I think that's probably about it, really. Now, of course, none of this is going to work because these are model sets. So in order for this to work, what we need is to try to okay, we're still getting quite a few errors. Let's see. Okay, perhaps this is just these guys here. Now, model set does not seem to have a name, which is unfortunate. Yes, it was really not designed for us to operate at the model set level. We're getting stuck into a lot of detail here, which is really annoying. Well, the only alternative to make our life slightly easier, and this is all one big hack really, so let's just continue the hack. Let's just say, instead of operating at the model set level, I'm going to operate at the model level. Somebody else would have to look through the models, and it's just this. We have to keep in mind this is just something we need to do for now, so it doesn't have to be particularly brilliant. It just has to work. So what I think to do here is just forget about model sets for a second, because otherwise we're just going to spend a lot of time here faffing with model sets, and we can get all of this for free if we think at the model level. Right, so what we'll do is just this. Model will now have a name. Well, it doesn't, but the logical model will. And we need the context. Okay, so I think this will give us what we need, which is right. And the job now will be of the person that's calling us to loop through the model sets, which I think is fair enough, really. So let's just do that. First, let's just get this thing to compile. Oh, I think we're going to have problems because we forgot to update the model sets. Right, so what we're trying to do now is just to get this thing to compile with this move. Hopefully we'll get it now. That's looking good. While we wait, we start the commits. So here we're saying something like, okay, compiled, so orchestration, implement, legacy, dependencies, transform. And now that we've implemented it, the next thing we need to do is to hook it in. So we need something like this. And we just need to remember where it should be, so logical So this is the projector. Right, so this is a transform, and then if I just in here, if I do something like this, I can apply here with the context dot text context, and this guy would now be of course. Now the problem we're going to have presumably is that we oh yes, we do have R. Okay, good. So finally run the legacy dependencies transform to update the include directives. Okay, cool. And now what we really want is for this thing here not to break anything. Bit of water. Which I think it won't. It didn't, so we can now say something like orchestration hook in the new legacy dependencies transform, which is what that guy does. And now we can remove the previous incarnation of this guy, which is this guy here. Wanted to make sure we removed it after we hooked everything in, so we didn't lose any code. And probably will need the usual conversions. Righty, and if we just generate one thing I think I forgot to do. Right, so now we get rid of the old transform. Let's just get this guy to run all tests while we commit. Oh, error. Oh, okay, fine. See what this guy's saying to us. We forgot, of course, to remove right, so a bit of luck. It should now work. Not exactly why we're getting some areas highlighted there, but there you are. Hopefully Max will sort itself out. So physical, remove legacy dependencies transform. I would love to know how we can select entries in this, but at any rate, let's not waste too much time on that. Okay, cool. So now what have we done? We all of this to move the transform over to orchestration in the right place. Now we got the transform in the right place, we can start to think about what the transform should be doing. And there it is. It has computed the directives, and now we've got the directives. We have to think about what we're trying to do then. So we need to loop so if we loop across our logical physical regions, and then if we say well, presumably these can't be consts. If we say then that the region is basically the region pair dot second, Oh, actually, these are not pairs. Let's have a look at what the logical physical model is saying. It's just a list. Okay, so it's a logical physical region. So this is a region. And what does the region have? Oh. A region has a physical region and a logical element. So the first thing we need is the elements. And then what we're going to have to do is we're going to have to dispatch this element to its right type. So we have some functionality to do this. Should be easy enough. Let's have a look at our RG area. So if I look at any transform, probably across the board. I'm not sure why company mode was enabled in the first place, but RG. So what we really want is the little helper that we have in the logical model. The elements transversal. So this guy here is used all over the place. We choose one of these transforms as an example, and what we'll see here is interesting. Okay, it doesn't look like we're actually doing anything with it here. Let's try something else. Right, okay, here we are. So this guy here, doing some kind of projections, has got an implementation. It turns out it's a very basic implementation, doesn't do any type dispatching, so it's not ideal either. Who would be the guy that's actually doing something sensible with a bit of dispatching? Not this guy. Perhaps a decomposer? We have a lot of examples, but sadly none of the examples are doing what we want. Ah, yeah, decomposer. Lovely, that's what we need. So the decomposer is making use of the elements transversal, which is what we need, and is defining a set of overrides, which are these guys here, for the dispatching, which is exactly what we need. So what we'll do is we'll create a local class here. What name should it have, I wonder? So what's the job of this class then? Its job is going to be to dispatch the logical model elements to their right types, and then once we've dispatched it, it's going to well, presumably we'll have to compute. Yes, so it will be the inclusion. Well, actually, I think we should call it inclusion builder, because that's what it's going to do. It's going to build inclusions, right? And then what we'll do is we'll go back to that decomposer of ours, and we'll copy these guys here. And I think we just need to now say logical for all of them. We're going to need many more than these, but this will get us started at any rate. So this dispatches to the right element type, and then once we got the right element type, we then need to find the right archetype. So that's fine, we can create some methods for that. So let's think about this then. So will this return a result? Probably. So we probably need something like the thing we're building, text model, I guess. Well, we just update it in place, I think, so we don't really need a result because we will update it in place. We will need some state though, so we'll need our reference to the text model, and we will need a constructor. That takes this guy. Right, so area. So this guy's job is going to be very simple, so I think we can just implement it here. Doesn't really do very much. So the job of the constructor will simply be to remember the model. In fact, that's actually not quite right, because we need to remember that we are... So how does this work? We are inside of a loop, and that loop is giving us elements, and then the magic of the traversal will give us the dispatch to the right element. Once we got the right element, so this is where things become interesting. So we got the right element, now we need to find all the artifacts for that element. So we need simultaneously the element and the region it belongs to, because without the region we can't access the artifacts. So this is not exactly the trivial dispatch that we're used to, because in a normal dispatch we just locate the element, get its type, away we go, everyone's happy. But in this particular case, after dispatch we need to know the context of that dispatch, and the context is the logical physical region. So, but having said that, what we can probably do is, I mean, we don't really necessarily need to know anything about the logical physical yes, okay, I get it now. We don't necessarily need to know anything about the logical physical region all the way up to the point where we're about to insert the artifact. So if we can create a builder, and if we could say to the builder, here's the region. So instead of having a model as inputs, the builder will have two things really. This guy. So let's start off with something like this. So we'll have some kind of inclusion directives, right? And not exactly the best of names, but if you bear with me for a second. So the inclusion directives are here. This could be by reference really, we don't particularly care. And we need, as with the model, we need to remember what the IDs were. Inclusion directives, not the best of names either. Right, okay, cool. So you're remembering the inclusion directives, right? This is the global inclusion directives, bear in mind. But the key thing about this is that the builder will kick in for a given region. Now that's the important bit. The builder needs to know the region it's in when it's building. Then it will, instead of the model, what we really need is the region. It would be nice if the builder could I mean, I'm just, this is not really the cleverest thing in the world, but we'll have to do for now. So let's go back to the text model. Let's take one of these logical physical regions, and let's just say that when you prime this guy here, you prime it with a region, and it remembers the region. Because it's going to operate in that region. Right, so what is happening then? So we are taking the IDs. Okay, we must remember. No, actually, to be honest, this can perfectly well be const. Nothing wrong with that. So, now then, the inclusion builder takes the unordered map that contains all of our lovely inclusion directives, takes the region as well, remembers the region, not entirely sure why, binding reference number to stack allocated parameter IDs. Did we forget to pass it by reference? Right. There we are. Now then, we remember the regions. Now we remember that region, and we remember the inclusion directives globally. We will resolve this guy to a specific element, and then once we've resolved it, we will look at the region and do this thing. But now the key thing to remember, of course, is that in the past we were used to inclusion builders that operated in models rather than regions. So this is going to be a bit of a special builder. What we'll do with it is we'll create the builder here, and it will be created, so let's call this B, and the builder will be created with the region, and we're forgetting something, aren't we? The IDs. Right, and then as with the decomposer, we will transverse but of course the problem is no, actually, so what we need now is just a typical visitor. That's the problem. We're just getting a bit confused here. We don't need a transversal because we're not transversing. We need a visitor. So logical element is then element visitor. Right, let's what is this guy then? So in here, hopefully there's the element. There should be an element visitor of some kind. There it is. And now what we need is an example of how exactly this element visitor works. A lot of stuff. Now these are all things that are deriving from visitor, so we don't care. This is the visitor itself. And here we have something that's actually making use of it. So we just create a right, so this is the helper expander, right? So if I just have a look at these contents. Right, so now this guy becomes a visitor. And because it's a visitor, it needs to remember what it's visiting. So let's just have a look at this guy here. And visit will now be something like, well, I think we can probably very quickly convert this into visit. Something like this. Righty. So, inclusion builder will take those two things, will visit, but the visit will dispatch, and here what we really want is inclusion builder. Of course we needs to put the parameters in order. Right, then there's the inclusion builder, and then we can just do something as simple as e.visit. And now I think the problem here is probably that we don't have elements, and now we're going to need a lot of elements here. So let's just grab a whole load of them. Well, it's only 2, sadly, but there we are. You're going to need a lot more than that. So you're going to need the elements, and now we have object and primitive. I wonder if our RG gave us anything else. Not a lot, to be fair. This guy here might take more than one. No. No, okay, so we'll have to do some legwork here, but it doesn't really matter. So, there we are. Now then, we go for visit. And then in visits, we want to use the builder, of course. We don't need to transverse, right? Now element should have had a visit. Sorry, not visit. Apply. Now we remember our visitor pattern correctly. I think we haven't done this in a while, so let's just again look at our example. Helper expander. You would have thought around here somewhere we would create the visitor. Let's have a look at how the visitor is being used. Things are all very obvious when you accept, of course. So the visitor accepts, the element accepts. I don't know why I was thinking of apply. It's because I was thinking about transforms. This accepts the builder. Right, away you go. So now then, what are we doing then? We're looping through each region. In each region we locate the elements. In the elements we accept that element. And then the accept is going to trigger all the sorts of weird and wonderful things. It will contain the region. It will apply whatever updates it needs to the region. By the time we're finished here, we're done. So that's all good. Of course, there shall be many types that we need to visit here. So one possible thing to do is perhaps to let's think about this. So what's the easiest way to get all visits? That RG did not give us a lot of matches, so I don't think we're using the visitor very often. I think the trick is that the visitor contains some kind of filtering, right? So we're basically saying that if there is none, then we probably go to object, I think, to element, that is. And so I think it's alright for now. As we go along, we'll just have to add more. One slight problem here. No, I think it's fine as well, because it's const and we're not const, so I think it's fine. Right, so if everything is gone according to plan, then the visit. Oh, actually, now what we're missing is the builder interface, which will also be part of this guy. So let's just have a look at the builder. And what we're going to do is the builder will be we'll be doing all of this stuff, including whether it is enabled. There's going to be some challenges ahead, I think. There we are. The builder will need to do all of this stuff. It's part of this builder interface. So I might have the private there already, I think. Right, here we are. So a whole load of stuff. Now, while we're here, we need to update some of these things. That's fine. That's fine too. Okay, it's all looking good. It's rather surprising I managed to get all that through. Now, what else do we need? So we have the directory group repository. We are constructing a set of dependencies. Now, there's two ways of doing this, really. We could be lazy and we could just say, well, you're doing this for the whole region, so don't bother constructing a set of dependencies, because we need somehow. So there's two bits of functionality here, right? So the first thing is we need to construct the dependencies, then we need to slot that back onto the artifact. And we need one of these per artifact. However, the inclusions builder, So you can already see what we've done here. We've mixed the responsibilities of building with the responsibilities of looping through the region. The builder thinks in terms of a single artifact. The inclusion builder thinks in terms of the region. So I think we need to separate them again. I think we need two classes, and I think what we'll do is the usual hackery. We will just copy these guys across. I think they'll be fine. So now we will still of course need all this builder stuff, that's fine, because we need to pass that on. But our dependencies builder is going to be a bit more clever now. It's going to basically say, give me one of these guys, which is equivalent to that, and give me the enable architects for elements, which I think is equivalent to that, and that's fine. And then this guy will basically say, yeah, whatever, just give me the inclusion directives. And I think, believe it or not, this is probably sufficient. I don't know why LSP is still not up to date, but that's fine. And then what we'll do is we'll keep going. That seems to be slowing down a bit. So we have dependencies. What did we call these guys? Inclusion directives? No. Inclusion directives, that's the name. While we're here, let's make sure that we don't mix and match. So this guy does not need all these responsibilities. Now his job is visitation. Okay, so this guy visits, the other guy builds, and they're all private, that's fine. This guy will be pointing to this a reference to the inclusion directives, and we also need the enable architect for elements, which is fine. So all we have to say is to say that this guy is supplied as an argument when you build this guy. And that's also quite straightforward. Right, Emacs seems to be very, very unhappy, so we will have to sort it out in a second. But first, since we know what we're doing, we will take the dependencies builder and then make that guy the property. And so now then, we can just basically say construct the builder, like so. I think we just call it a builder, didn't we? And the builder will be constructed using a set of IDs, the enable archetype for element, yeah, and that should do it. And we will remember the region and Bob's your uncle. Right, so now then, what we need to do is to get Emacs to sync again. Seems a bit unhappy at the moment. Just a quick tire jump, I think. Clang D is probably overheating. See what we're doing for time. Oh, an hour and a half already. Right, there we are. So, no matching construction installation of the inclusion builder. Right, so we're missing something in the inclusion builder. Now, of course, we shouldn't really call this inclusion builder, but so we have a dependencies builder, and then we have a region visitor, maybe. Not the best of names, but get the gist of what I'm trying to do here. the region visitor will have to visit the region, and then what we need for the region visitor is to remember these enabled archetypes. So the enabled archetypes is probably stored somewhere very insane, such as the model, meta model properties side of the physical model. So if I just get that, and that's going to be something like m.physical, x m.physical dot meta model properties, and in here we'd have the enable so let's just get the MMPs first. And then if we then say right, this is probably going to be IDs first, presumably, followed by the MMPs, and ultimately the region. And right, so then I don't know why, but I'm getting to this habit creating little variables for everything. It's probably not a very good thing. It just makes the code slightly more readable somehow. Don't know why. Okay, cool. So then, what we're doing, we are looping to each logical physical region. We are passing this to the region visitor. I don't know if region visitor is a really good name, but region processor, maybe region, I don't know, region handler. It's not really visiting a region. I'm just going to call it region processor because it's slightly less confusing. So the region processor is also an element visitor. Okay, and then the element accepts the region processor. The region processor is then going to construct the builder, which it did already. This is going to be a very, very large transform, I think. And then, now that we got all of this stuff, we can, well, I think the next thing we need to do is to implement the builder for anything else. At this point in time, I'm starting to think that we're probably better off actually constructing a builder separately, because this is going to be one gigantic, humongous file, even for something that has to live temporarily. It looks a bit much. Waiting for time. The time is... yes, a bit late. So, what do we need to do here? Well, we have two options really. We could extract some of this functionality out of the transform, because if you have to remember, this transform, in addition to all of this madness, we still have to have a function per artifact. We really can't afford to have the builder plus the visitor all in one file. It's going to be thousands of lines. We can extract some simple stuff out. So perhaps we were right in saying that we need a builder helper as a helper, because it's just to preserve some sanity in this, because otherwise we will not find anything in this model ever. Yeah, we already have some helpers here, so I'm just gonna give up and allow a temporary class here. So just move these guys a little bit. I think we're gonna end up having to break this halfway through, because there's still a lot of work to get anywhere close to finishing this transform. So we will just create a dependencies builder, just copy it instead of pasting. Yeah, what we'll just do is we'll just create a dependencies builder helper here, because I think things are getting a little bit out of control. And this guy's job will just be to build this. Not going to bother too much with all the details of what this thing does. Right, there we are. So the job of this guy will be just to build, and its color, usual E5E. And then the idea would be that the legacy dependencies transform will make use of the builder, as you can imagine. And so this makes a bit more sense, right? So we'll just move the builder across to that guy. It is still pretty clean, I guess. It's still not going to have too many dependencies because we just have a constructor. It's very generic types, really. Inclusion directives are part of the physical model, so everything's fine. Right, the physical ID is fine too. So okay, I think we're going to have to pause here for a second and then continue in the next video. But what we've done, which is not a lot really, but what we've done in this video is we've figured out the logic of where to put the transform that's going to be doing the inclusion, and in a way that fits the model rather than the way we did it before. And we now more or less know how to implement the transform, but we just got the skeleton up and running, I guess. So in the next video we'll work on actually implementing the transform, I think. Okay, that's all for this one. Thanks for watching.